You remember the exercise we were doing last time?
Yes,
The
teacher.
internet disturbed us. We went away unceremoniously.
Yeah, remember.
I remember Marilyn was our secretary then. She was still telling us what she has summarized.
I think we finished.
Finished, huh?
Yeah.
Okay. So what are we meant now to be covering? As in a continuation, if we are not going backwards. We finished with the conversion of units. I don't know if I can get the senior one book here and I see which topic is supposed to be next. We want to start moving forward, eh? Not going backwards. Aisha, I'm looking for the book, or if anyone has the student's book, we can tell us which topic is supposed to be. I think after density, many of you had covered the density. What comes after density?
Teacher, I'm not sure what comes after density because density is where you got us from. It's where we ended from school in some classes.
Density, and we wanted to follow the real arrangement of topics according to the senior one textbook. Huh? That's what I'm meaning. According to that, let me look through the book here. Through the book. Documents. Teacher's guide. Can't. Okay. Hello? Yeah. Okay, please. Open. You people should be having these books nearby. Now it's taking too long to open, but it is open now. Good enough. According to the contents, under measurements, there was estimation and measurements, scientific measurements, measuring length, measuring area, measuring mass, volume of irregular objects, measuring time, the use of scientific notation and significant figures, scientific notation, the scientific method, meaning of density, the density of different substances, comparing substances with the same volume, change in density and its application on flotation and sinking, floating in the sea, does floating occur in air, ocean currents and water. So I think many of us had finished up to the density of different substances. Had you talked about comparing substances with the same volume? You
Yes.
unmute.
Yeah.
Yeah, we did in some classes.
In some classes.
Stream.
Come again? In some streams.
Yes, teacher.
Do we have anyone whose stream did not cover this?
Cover
I
what?
think North
Covering,
maybe did not.
comparing, let me see, comparing substances with the same volume.
Ours
That comes
did.
after the density of different substances, and there is comparing.
It didn't.
This did not. Okay.
It did not. It
All
did
right.
not.
Okay, so we are going to look at that one now. Okay. Changes in density, its application, flotation. Okay, so we are starting from there. Someone's hand was up, good enough, it is no longer there. Good. Comparison of comparing substances with the same volume. Now, for those who attended the last lesson, we had an example where we got a scenario that I don't know who was buying furniture. Which name did we use then? Who was buying furniture and needed our guidance on choosing the best quality wood?
Amira.
So Amira was buying furniture. Now what we did, we said that we get samples of the different available types of wood, and then we determine their densities. Because we said if we can't just determine by weighing using our hands, because something can appear heavy, the reason it is very big in size, while another one appears light because it is just small in size. Now, where our hands can work better is a case where you have the two samples having the same volume. For example, if I cut out a sample of wood, which is the size of this speaker, from wood type 1, and I also exactly cut the same volume from wood type 2, at that point, I can use, somebody is saying this is exactly our first lesson of physics. What did we cover? There was no big deal. The examples we are looking at were in the form of activity of integration. And so the questions were in the form of scenarios. Actually, the question was, if I can recall, Amira wants to buy furniture, and when he visits the carpentry workshop, there are different types of wood available, but she wants to choose the best quality type of wood to make her furniture. And now as physics students, we are required to guide Amira on how to choose the best quality wood. In summary, we said she just needed to get the density of the different types of wood. Reason being, density is known to be a quality or a characteristic of the wood itself. If the density is high, then that wood has best quality. If the density is small, then the quality is low. So we said what you do, you pick different samples of the available wood. You said, supposing you have wood A and wood B. Then you can even be wood C. Suppose we have 3 types. So we said we pick a sample of this. We cut off some sample. This can be a sample from wood A. We also cut out a sample from wood B. Can be like that. We said the shape may not be regular, may not be constant. And then you have another one, maybe this one is in the form of a sphere, for example. Okay. So we said we just get the samples from each of these types of wood. And what do? We determine their masses. Supposing this is mass 1, mass of A, mass of B, and mass of C. We said in our answering, we must mention that the masses of the different samples are obtained using a beam balance. We should mention this instrument which Amira should use to determine the mass. Don't just say determine the mass of wood A, determine the mass of wood B, and determine what mass of wood C. What should Amira use? Because assuming Amira is not a student of physics or has never studied any physics, and therefore she doesn't know what instrument is used to measure mass. So in our answering, we should mention the instrument Amira should use to determine the mass. So we said we determine the masses of each of these. Then procedure 2, we determine the volume of each of these samples. If the shape is a regular shape, for example, wood A, we know the other one is a cuboid or a tube, where we can measure the dimensions, we can measure the length, we can measure the height, we can measure the width. Then we know we can determine the volume by formula. Length times width times height. But if the shape is irregular, for example, wood B and maybe wood C, supposing it is not a regular shape, then we can use the displacement method to determine the volume of such a sample. That's what we said. So we said again, in answering, we don't just say determine the volume of each sample. We again bring the other assumption. Supposing Amira has never studied any physics and therefore doesn't know how to determine even the volume of an object. So we mentioned that we determine the volume of each of the samples by either using a formula if the sample is a regular object, or by the displacement method if the sample is an irregular object. Someone is still asking the question. Let's first finish answering. We shall repeat the question for you. So we are saying in our answering procedure 1, determine mass of each specimen using imbalance. 2, determine the volume of of each specimen. By formula or displacement method. Then determine the density of each wood type. By the formula density is equal to mass over volume. That was the brief outline of what we advise Amira to do. And then the conclusion is that the wood sample or the wood type with the highest density is the best quality. And therefore, Amira should choose the wood type that has the highest density. That was our answering. Someone who was asking what was the question about, we said the question was that Amira wants to buy furniture. Amira visits a carpentry shop and finds different types of wood that can be used to make the furniture. But Amira wants the best quality wood. But remember, she's not a carpenter that she knows the quality by mere seeing. Now, as physics students, we are required to advise on how Amira can determine which type of wood is the best. I don't think the chalkboard is blurry unless your network is weak. Is it the case with everyone? Ashley,
Yes, teacher.
Ashley, is your chalkboard blurry, yes. Ashley? Elisha?
Yes, teacher.
I think it is, would it be my network? But if it is mine, then it should show you on your screen that the host's network is weak. I think it is your side, network on your side.
Teacher, it's your side.
My side?
Yes, it's your side.
I think it's the other person's side because mine is okay.
Yeah, mine is okay.
Once any one of you has which is okay, then the problem is on your side. Once the problem is on my side, everyone will be affected.
Teacher, it's
your okay. Network bars are red, teacher.
Are red? Eh? Let me put it in a better place.
Yes.
Let me put my
Wi-Fi. Mine are white.
But mine are white, now are yellow.
Yeah, mine are white.
At first they were white, now they are white.
Now they are yellow.
Mine, eh? Network keeps changing, don't worry.
Yes, yeah.
WhatsApp number.
What does white, yellow, red mean?
Red means it is completely very weak. Yellow, it is there alternating, not very good, not very bad. And the white it is stable, it is good. Okay, back to the physics. So the one who was asking about the question, have you understood what we were answering? I didn't speak the name.
Yeah, my connection was a bit unstable.
All right, good. Now, today we want to look at comparing substances with the same volume. Now, in this one, we first discussed as a class, and we said, what can we do to help Amira choose the best quality wood? Some of the assumptions were, someone suggested that the Amira should be given 2 samples of the different woods, and then by weighing, you are holding one this side and one this side. You try to weigh out which one is heavier, and we choose the one which is heaviest. And now we said the challenge with this is that supposing this sample by size or volume is bigger than the sample in this hand, will it be a correct basis to say the one which is heavier is the best quality? We said no. One can be bigger and it is heavy because it is big, and the other one looks light because it is small in size. That's why we said no, we have to advise Amira the scientific way. We should not rely on just holding in two hands and make a conclusion. It is not a scientifically reliable conclusion. We said we better do the experiment. Now we are saying, coming back to that argument, it was not a wrong argument as such. That method can also help us to determine which body has a greater density than the other. However, the condition here is that for us to rely on that comment, on that argument, we must be very sure that the two bodies we are holding in our two hands are exactly of the same volume. If they are exactly of the same volume, that means the same size. And we hold one here and one here, and we feel one is heavier than the other. It is a clear indication that the heavier one has a higher density compared to the light one. Only and only if our samples are of the same volume.
Volume.
Are we together?
Yes, teacher.
Yes, teacher.
I'll give an example. Supposing we put paraffin in a jerrycan of water and it is full, 20 liters. We also put in another jerrycan, 20 liters of water. Which one will be heavier than the other?
Water.
Water.
Water will be heavier.
Yes.
Water will be heavier. Now, the fact that there are 20 liters of the water and 20 liters of the paraffin, that means they are equal in volume. But we realize that water is heavier than the paraffin, even when they are equal in volume. Then we can reliably say water is denser than paraffin, or the density of water is greater than the density of paraffin. Reason?
Okay.
Water is denser when it is exactly the same volume as the volume of the paraffin. That's what we are dealing with, comparing the substances with the same volume. Now this one, though it is not part of our syllabus, for now, it comes later, brings us to what we call relative density. And that's what we want to look at. What we call relative
density, volume.
density. Now, relative density has two definitions. But the first definition is, anyone with an idea what relative density is before I put mine? This curriculum, we are supposed to build on what you have. Huh? Yes, Elisha?
Relative density is the ratio of the mass of a substance to the mass of an equal volume of water.
Okay, that's one definition. The ratio of the mass of a substance of an equal volume of water. That's one definition. Like I gave an example of paraffin. Like you have 20 liters of paraffin. If, for example, when we measure the mass of these 20 liters, the mass is, for example, maybe 17 or 16 kilograms. Then we also measure 20 liters of water. When we say water, we are meaning pure water. And we realize that the mass is 20 kilograms. Are we understanding these two statements? When I'm very far on the chalkboard, I may not be able to read the messages in the chat room. It is better when you have a point, you raise up the hand like Najinda. Najinda, say something.
Teacher, I just wanted to give another definition of relative density.
Okay, don't worry, it will come. If you remind me, it is you to give us.
Relative density is the ratio of the density of a substance to the weight of an equal volume of water.
Okay. I think here you are just changing through the word mass to weight. In this case, we shall consider them as being together. We shall see the relation. It is still fine. Okay. So I was saying we measure 20 liters of paraffin and we get its mass. We measure 20 liters of water, we get the mass. This is that the volumes are equal, 20.
Yes.
But the masses are not
That's
equal. So according to this definition, if you want the relative density of paraffin, we are saying the relative density is going to be the mass of the substance, which substance in this case is the paraffin, divided by the mass of an equal volume. The paraffin was 20, the water must also be 20. Now we compare the masses. So it will be 16 divided by
20.
This will give us what we call the relative density.
4 out of 5.
Does it give 0.8? Is it 0.8?
Is it a must? We have to change it into a decimal, or we can leave it into a
Yes.
fraction.
We prefer it as a decimal.
Okay.
Now, one thing we should also realize here is that 16 was a mass, and therefore it is in kilograms. 20 was also a mass, and therefore it is also in kilograms. So when we divide, the kilogram cancels because they are the same units, and therefore the answer for relative density has no units. So relative density has no units. Are we together?
Yes,
Someone is defining, Mariam says relative density is the, let me go through some messages here, probably is important information. But I request that we be using the verbal, because when I'm on the chalkboard, I may not see that there is a message that has come in. And it only shows for a few seconds and then it disappears. The relative density is the ratio rational. Now you have to be careful with the way you write words. Now this one says rational. The meaning changes. Ratio is different from rational. But I'm sure you wanted to mean the ratio of the substance to that of water. That statement is not clear. In physics, we talk in terms of measurable quantities. So when you say the ratio of the substance, what are you meaning? The volume of the substance, the density of the substance, the mass of the substance, or what? We have to be specific in physics, which quantity we are dealing with. So that one needs revision. Joelia focus. So we are not writing. By the way, in this curriculum, it is you to make the notes. Is the ratio of the density of a substance to that of water. I think we have to take this definition from Hamid Haira. That is another definition. She's giving us another definition. Is the ratio of the density of a substance to that of water. What is that one again? For this one, we have understood what it means. I've given that example. Same volume, then we compare the masses. Hamid gives us another definition. This is the ratio of the density of a substance the density of your water. That's very good. What does this one mean? Supposing they tell us that the density of paraffin is 800 kilograms per meters cubic, and the density of water is 1,000 kilograms per meters cubic. Supposing we know the densities of the two different substances, water and the other substance, under consideration, then the relative density says it's the density of that substance, in this case paraffin, if it was paraffin, divided by the density of pure water. And in this case, this would mean 800 divided by 1,000. Are we together?
Yes,
Yes,
teacher.
teacher.
Good. Does it still give 0.8?
It does.
It does.
So again, we have to realize that this density, the 800 is in kilograms per meters cubed. Even the one at the bottom is in kilograms per meters cubed, meaning the units cancel out since they are the same. Huh? And again, the relative density, our 0.8 will have no units.
Yes.
So it further emphasizes the fact that relative density has no units. Now, I want us to see, is there any relation between this formula, this definition, and this one? We can check whether they mean the same or not. Now, from the first definition, we said relative density is equal to mass of substance over mass of equal volume. Let me drop this one first. No. Anyone who knows the formula for determining mass of a substance? Anyone to remind me, or who remembers? How do we
Excuse me,
determine the
teacher.
mass?
Density times
You're
volume.
blocking the good
I'm blocking what?
blackboard.
Hey, we are not dealing with anything to do with this. I'm interested in that. You were writing. Okay. Okay. So I was saying, who still remembers the formula for determining the mass of a substance, say from volume and
Density
density?
times volume.
Density time multiplied by
Density times the volume, eh? Good. That means this formula here
Yes.
can further be written as, instead of writing mass of a substance, I'll write density times the volume of substance. Up here is it for the substance, huh? Over. The same formula applies for water. So even where we are saying mass of water, we can say that means density of water times the volume of the water. This is for water. So the denominator is to do with the water, the numerator is to do with the substance. Are we together?
Yes, teacher.
yes, teacher.
But remember from the definition we said equal volume, meaning the volume of this substance is the same as the volume of the water. If this one is 20 meters cubed, even this one must be 20 meters cubed. If it is 5 meters cubed, this one must also be 5 meters cubed. Why? We only compare equal volumes, masses of equal volumes. What does that one tell us? That then this volume will cancel with this one. Not so.
Yes, teacher.
Because they must be equal according to the definition. But the densities are not equal. So what do we remain with therefore? We are remaining with the density of the substance over density of water. Density of substance over density of water. Isn't this one here? This is still relative density. Isn't this definition? That formula meaning the second definition. Do we realize that?
Teacher.
Yes, teacher.
Yes, teacher.
So it means that these definitions are actually the same. One is coming from the other. Are we together? One is coming from the other. Now, before we do examples, I want us to realize that density is related to whether a body should be able to float, say in water, or should not be able to float in water. How? If a body has a relative density which is less than 1, because remember this one is going to be a fraction. If the density of the substance is greater than the density of water, the relative density is going to be greater than. When the relative density is greater than 1, is when the relative density will be equal to 1. Is when the relative density is going to be less than 1. Who can tell us, who can, by giving maybe examples, how those conditions are possible? When can we have relative density being greater than 1 using any of those formulas? Can I hear from people? When can we have, say, using this formula here? When can our answer for the relative density be greater than 1? What can be the condition? Are we together?
Maybe if it's equal
Yes,
to 1.
teacher.
Okay, there are hands up.
It's when
Rihanna first. Yes. Najinda first. Okay. You were speaking already.
teacher, it's when the density of the substance is more than the density of the water.
Very good. Do we all realize that if the numerator is greater than the denominator, the fraction will be greater than 1? Do we realize that?
Yes.
Now, in such a case,
Yes.
teacher, do you mind repeating about the formulas you wrote? Okay, we shall repeat, but let's first finish this concept. So we are saying, if the density of the substance is greater than the density of water, our relative density is greater than 1. Now, this one means such objects whose density or whose relative density is greater than 1, all such objects will always sink in water. Because it means such objects are heavier than water. Are we getting the point? We are now talking about sinking and floating. Sinking, submerging, floating. A body will sink if its relative density is greater than 1. Are we getting the point here? So in a question I can say,
Yes, teacher.
In a question I can say, gold is known to be denser than water. But some girl comes across a piece of rock and she claims it is gold. And they don't have other equipments to measure the mass of gold, the density of the volume of gold, and so on. Then we ask you, how can you quickly help her to know that it is either gold or not gold? Temporarily, because there are many rocks which are denser than water. So sinking may not be enough to say it is gold, because even copper will sink, diamond will sink, and so on. But once it floats, then it can never be gold, because gold is denser than water. So do you see that that one can be the quickest test, first of all, to have reliable information that it is, maybe it is gold or it is not gold. You tell someone to put it in water. If it floats, it is never gold. Gold cannot float. So that is sample one, but it does not confirm that it is really gold. But at least there is those preliminary tests. Okay. When is the relative density equal to 1? When can the relative density be equal to 1? Under what condition? Joeria, at this time, my son. Hey, Najina, you have been answering. Let's hear from Rihanna Agnes.
When the density of the substance is equal to the density of water.
You realize that when the density of the substance is exactly equal to the density of water, then the relative density, this fraction will be equal to 1. Supposing this one, the density is 1,000, and that of water is also 1,000. When you divide it, it will become 1, not so?
Yes.
Such a substance will not sink in water, neither will it float. We say it submerges. It will submerge. So it will be partly in the water. Have you ever put something in a saucepan?
Can you repeat that?
Okay.
No, no.
Have you ever put an object in water and it remains in here?
Yes, I have.
Yes, teacher, I have.
It is neither floating. It is neither floating on the top, nor sinking
at the
completely.
bottom. So what is it doing, teacher? It's floating
We
in
say
water.
it is submerging.
Okay.
Is what submerging. Then, what will be the condition for the relative density to be less than 1?
When the volume is less than the, no? When the volume is,
Volume?
when the density is less than the water, than the density
of water. When the density of the substance is less than that of the water, take an example.
It is
supposing the
less
density
than
of the
1.
substance is 800, and yet the density of water is 1,000. See that the density of the substance is less than that of water. Automatically, the answer here will be less than 1. Now, such a substance will always float on water. Once the density of the substance is less than that of water, the object will always float on water. An example is when you mix paraffin with water, even if you shake them hard and then you let them settle, you'll always realize that the paraffin is going to come on top and the water will be at the bottom. Why? Paraffin is less denser than water. And therefore, when you get the relative density of paraffin, it is going to be less than 1. And therefore, at all times, paraffin must float in water. Are we together?
Yes, teacher.
No, we are not together.
Teacher,
Yes, please.
I have a question related to
Yes.
relative density.
Okay.
I've understood everything, but I'm asking if density is specifically made for only water. Like, is it something for water? Or
Very good. Now, relative density is specifically a comparison with water.
Oh, okay.
Whether you are talking about the relative density of solids, whether you are talking about the relative density of gases, whether you are talking about the relative density of liquids, they will
Yes.
be in comparison with the water, specifically water.
Okay. Thank you.
So the denominator must always be density of water or mass of an equal volume of water, not any other thing. The numerator can change, but the denominator remains water. Are we together?
Yes.
Yes, teacher.
So what I wanted to say here is that someone has said we repeat this one, maybe quickly. I hope she's online. By definition, the first definition we said relative density is the ratio of mass of a substance to the mass of an equal volume of water. Equal volume, meaning the volume of the water must be equal to the volume of the substance you're talking about. But when you convert this English into mathematics, the mathematics becomes this. So this statement, this mathematical statement is exactly the same as this English statement. We have converted English to math, it becomes this. And then we
Teacher, I
reminded
wanted to
ourselves.
If that's the statements you have been saying about if the density is less dense than water, it is relative density is less than 1. I wanted to say, can we say if the density is less dense than the volume or density of water, it is relative density less than 1? Is that also correct?
It is also correct.
Okay,
But
thank
we
you.
can only have relative density being less than 1 if and only if the density of that substance is less than the density of water.
Yes.
And we can have the relative density being equal to 1 only and only if its density is equal to the density of water. We can have relative density being greater than 1 if and only if its density is greater than that of water. That's very correct. And a good summary. So, after we converted our English to mathematics, we said, but we know the formula for mass from this triangle of ours. This is mass, this is density, this is volume. This one means that mass is equal to density times volume. And therefore, we are substituting where there is mass of a substance, we are substituting it with density of that substance times the volume of that substance. And therefore, instead of the numerator, we wrote it as density of the substance times the volume of the substance. Likewise, where there is mass of equal volume of water, we are writing the density of water times the volume of water. So this formula became this. And then we said, since the definition was talking about equal volumes, then this volume must be the same as this volume.
Yes.
If this one we are talking about 2 liters, this was also 2 liters. If we are talking about 3 cubic centimeters, this must also be 3 cubic centimeters, meaning that the volume will cancel since they are equal. The one in the numerator will cancel with the one in the denominator. What we shall remain with is only the density of the substance over density of water, which is this one. And then we say this statement is the mathematical form of this English statement. The ratio of the density of the substance to the density of pure water. This word is when you change them into mathematics, they become this. So we are just showing that the two definitions are not any different. One definition is coming from the other. I think that one is now clear.
Yes, teacher.
Now, our summary here was that a substance whose density is less than that of water has relative density less than 1. Hence, such a substance not a very important statement. A substance whose density is less than that of water will have a relative density which is less than 1. And because its relative density is less than 1, such a substance will always float on water. I want us to know that something floating in water does not necessarily mean it can float in any other liquid. Okay?
Okay, teacher.
Just a moment. Hello? Yeah, I'm fine now. We proceed. Have we understood that statement?
Yes,
There are,
we have.
Yes, teacher.
there are two concepts we have to learn from that statement. That since the density of the substance is less than that of water, concept number 1, its relative density must be less than 1. Concept number 2, it will float on water. And I was saying floating on water does not mean it can float in any other liquid. Here we are talking about water, specifically water. Statement number 2, substance whose density is the same.
Is equal to water will submerge.
Same as that of water as relative density equal to 1. Hence, submerges. I think it's still understandable. And number 3, substance. Substance whose density is greater than that of water. Has relative density equal to, greater than 1. Hence, sinks in water. These are very important statements to note. especially some of the exercises we are going to do.
Thank you, teacher.
You're welcome. So let me see whether we can do some examples here.
Thank you, teacher.
You're welcome.
Thank you, teacher.
You mean we have finished? Or
Thank you very much, teacher.
We are not yet done.
People are going. Hey.
No,
We are not yet done.
no.
All right. We
We
want
are
to do some
copying.
example. We want to do some example here.
Okay.
I think I can remove all these ones. Huh? Clean out that stuff.
Blackboard frozen.
Teacher, is that 60 or 50?
50. Looks like 60. Maybe I didn't study nursery. During our time, there were no nursery schools. Uganda na Tanzania.
Mommy, I'm still in.
Yeah, we can see.
Okay. Okay, if you can see, just read for me what's after beam balance. Like,
A measuring
Okay.
cylinder,
okay.
1,000
Measuring
centimeters cube of
Measuring
water.
cylinder, then 1,000 centimeters cube of water.
Now,
1,000 what?
That's all.
Centimeters cube of
okay.
So we are going to do this number alone, or
Why not alone? In fact, an assignment. Have we all known that we have
How
learned
do
how
we
to?
find the density
Huh?
without the mass of the substance?
Hey,
There is
now
no mass of the substance.
in this
It's only
curriculum,
volume.
we look for they are what we call core skills. One of them is critical thinking. For example, if you are locked up in a house and the door is locked, can you think of other ways of getting out of that house other than passing through the window, the door? That's critical thinking. Until they open.
yes.
You see how we have divergent minds? Very good. Someone is saying, I can also first of all opt to pass through the window.
But if the window has bars,
Aha. Supposing the window is also having a burglar proof, shall you just die from that house because the window has a burglar proof? That's the critical thing.
That's the way to break the wall.
Yeah,
That is another method. Yes. Imagine if fire has started and you have a hole in the house. You mean you leave the wall because you don't want to damage the house when fire is about to kill you? Those are the divergent minds we want to create in you. Just imagine, if the person who invented a car did not try to think of other shapes, do you know that we would only be having cars which are box-like? We would not be having the new designs of cars we have now, because someone would say, but what is important with the car, as long as it is moving, then it remains like a box. I don't want to say like our old bus.
Of the resource.
So we are saying we must think outside the box. So for example, here I'm saying, someone is saying, but we don't have the mass. It is true, the mass has not been given. But what is the role of the beam balance? You see that?
So for us, we can use any.
What
No,
do you
there
see?
is
What,
I want being asked to describe the relative density of the oil, or just give like the relative density of the oil? So some of us do not have the imbalances.
we are saying describe how you can determine how you can. Meaning, mainly, we are looking at the procedures through which you should go through up to when you reach a point of calculating. So that even if someone came, you can give these procedures to someone who's very far, doesn't even know you. But if we followed the procedures you have stated, and for him, obviously, they will be having this water available and the other one, and therefore can measure, should be able to get the relative density. It is not your task to get the relative density, okay? But for you, you are outlining the steps. You are outlining the steps through which someone else or even you can follow up to when you can determine the relative density if you have the outcomes of the experiment. But when you don't have them, then you leave it at that point where you are remaining with just substituting in the values and you get the answer. You get the point?
Yes, thank you, teacher.
Welcome. So that is our assignment for today. It's already 1 sharp when our lesson should be ending. I want to wish you a nice lunch. Huh?
First wait, we want to take screenshots. First wait, I want to take a screenshot.
All right.
Thank you, teacher.
Now there is someone here who
Thank
is
you,
using,
teacher.
I will not mention the name. She's using a Katochi, but she also wants to take a screenshot. Do you think Katochi can take a screenshot? No way. Good enough, I will not mention your name. And Regina, I'm not saying it's Regina. Regina is using a tab.
Because I was taking
Okay. Nice lunch, guys.
We are not guys, we are girls.
Bye, teacher.
Bye. I said girls. This one.
We are ladies.
It sounded like this.
Are we done?
We are ladies.
Okay, ladies of substance.
Ladies, have a nice lunch.
Thank
We
you.
are not ladies, we have not produced.
Hey, you are ladies.
You're ladies.
We are girls.
You're ladies.
We are girls, not ladies.
Either way, they all
match
with it is called what? Masculine, the other than feminine. Woman, girls, all those ones.
Ladies.
Okay, even ladies. Okay. Nice time, girls. All ladies. All women.
Thank you, teacher.
All mothers.
Nice time.
Nice time. Mothers of the nation.
Teacher, we ain't mothers.
We aren't mothers.
We are not mothers.
We're not mothers.
One day you are a mother.
Just little girls.
You just
in the anthem.
You were mother.
Do you know the anthem of women anthem in Uganda?
No.
One of the verses in there says, "We are the mothers of this nation."
Nara.
It applies for
So
all
when
women.
your girl was already a mother.
I'm not a mother.